Hello students, this is Varun. We already have done with basic proportional theorem, which we also call Thales theorem. Now let us do the converse of basic proportional theorem. It can also be considered as the generalized case of midpoint theorem that we did in previous classes. And it states that if a line divides any two sides of a triangle in same ratio, then the line is parallel to the third side. Let we have a triangle ABC where it is given that AD ratio DB is equals to AE ratio EC, and we have to prove that DE is parallel to BC. Here it is given that AD ratio DB is equals to AE ratio EC, which we have mentioned here, and we need to prove that DE is parallel to BC, this one. And while students, we will do this theorem, we will solve this theorem by contradiction method. It means we will begin with the contradiction to this result. As we have to prove that DE is parallel to BC, so following contradiction method, we suppose that let if possible DE is not parallel to BC. Let DE is not parallel to BC. This is a sign of not parallel, and in bracket we should mention if possible. As DE is not parallel to BC, then there must be some other line passing through D which is parallel to BC. If DE is not parallel to BC, then we can think of some other line which passes through point D and is parallel to BC. And let us suppose that DF is the line which passes through point D, intersects AC at point F, and that is parallel to BC as well. So here we write, so let DF is parallel to BC. Since DF is parallel to BC, so in triangle ABC, we can apply basic proportional theorem. So in triangle ABC, as DF is parallel to BC, then by using basic proportional theorem, what we get? Since DF is parallel to BC, so AD ratio DB is equals to AF ratio FC. So we can write this as AD upon DB is equals to AF upon FC. Let this be number 1. Also it is given that AD upon DB is equals to AE upon EC. Let this be number 2, and we should mention this as given. So from 1 and 2, since left hand side of 1 and 2 is same, so we can conclude that AF divided by FC is equals to AE divided by EC. So here we write from 1 and 2, AF divided by FC is equals to AE divided by EC. Now further we will add 1 to both sides. We will add whole number 1 to left hand side as well as to right hand side. So here we write left hand side AF divided by FC plus 1 equals to right hand side will become AE divided by EC plus 1. Now we must take LCM and it will become AF plus FC whole divided by FC is equals to AE plus EC whole divided by EC. Now what is AF plus FC? What about AF plus FC and AE plus EC? We can see that AF plus FC is equals to AC and AE plus EC is also equals to AC. So we can replace numerator of left hand side by AC by keeping denominator same. In the same way, numerator of right hand side can also be replaced by AC by keeping denominator same. We can just cancel out AC by AC and we left with FC is equals to EC. We have proved that FC is equals to EC. Now FC and EC, they can be equal if and only if E and F are not distinct points. Means E and F are the same point, or we can even say that E and F coincide with each other. So here we mention which is possible. If and only if E and F coincide with each other. If they are coinciding, it means E and F are not distinct points. That is, they are same. Now we have proved that E and F represent the same point, and in the very beginning we considered that DF is parallel to BC, but now F and E are same point, so we can replace F by E. So we can even make the statement that DE is parallel to BC. Since E and F are same points, so we can replace F by E. So we concluded that DE is parallel to BC. But in the very beginning, we considered that DE is not parallel to BC. It means the thing which we considered in the very beginning, that DE is not parallel to BC, that is wrong. And we finally concluded that DE is parallel to BC. That is how we are able to prove this theorem. Hence proved. Thank you.